Hi, welcome to Data Analytics Part 2 course. I am Dr. Hemant Alisha, your course teacher. In first lecture, we cover basics of the natural language processing, starting with its definition and moving into its diverse applications. Today in lecture 2, we are going to discuss about web mining in business analytics. It's a similar sort of natural language process and web mining, all similar topics. Internet is overflowing with the valuable data. There are lots of important data within a data. So what people searching, post, review and click. Web mining help us extract insight from web pages, hyperlinks, and user interactions. So, web mining is helping us to extract useful, valuable information from the web data.
Web mining is process of extracting valuable information or useful information from the internet. Think about it. Internet is a virtual gold mine of data. Every search, every post, every review, and every single click tells a story. But how do we find the treasure in all that noise? Because data is all over scattered over, there's like a bulk of data. That's where the web mining comes in. It is the art and the science of using powerful data mining techniques to uncover brilliant insight from. So, before moving to more detail, let's see the agenda of today. What we are going to cover in today's lecture too. So, there are four main important topics that we are going to cover. First of all, we start with the web mining definition. Then we dive into the categories, types of web mining. After that, we cover the different techniques, method used in the web mining. And finally, we will see the application practical uses of web mining. So, first of all, what is web mining? Web mining is the application of data mining techniques to discover and extract knowledge from the web page or web data. This document provides an overview of web mining, its categories, techniques, and applications. It explores how web mining help organizations understand user behavior, improve web design or application, personalize user expressions or experiences, and gain competitive edge in the digital landscape. So, web mining is the process of discovering and extracting useful information and knowledge from web data. It involves using data mining techniques to analyze web content, web structure, and web usage data. The goal of web mining is to uncover patterns, trends, and relationships that can provide valuable insight for business researchers and individuals. So, web mining can be broadly categorized into three main categories. So, we will cover this in next. Next, we will see web mining techniques, and we will break web mining down into three core areas. Number one, web content mining. Number two, web structure mining. Number three, web usage mining. So, what is web content mining? Web content mining is what is actually on the page, the content of the web pages. Next, we have the structure mining. The structure mining, how are the page linked or interconnected. And third one is web usage mining. What are the users doing at the moment? What they are saying. So, throughout this lecture, we will explore each of these areas uh, in depth, uncovering how today's top businesses are using them to make smarter decisions, optimize their strategies, and gain powerful competitive edge. Next, we are diving deeper into web content mining, one of the three pillars of web mining. Web content mining refers to extracting useful knowledge from the actual content of the web pages, whether it is a text, image, video, audio. Let's walk through the four major types of text mining. Number one, four major types text mining. Number one, number two, image mining. Number three, multimedia mining, and real world applications. So now text mining. Text mining focuses on processing and analyzing unstructured data. Some of the key techniques include text classification, text clustering, information extraction, sentiment analysis. So what is text classification? It categorizes document into predefined labels. For example, uh, classifying email as spam or not spam, or support ticket into categories like billing, technical issues, or feedback. Then we have text clustering, grouping similar text data without predefined categories. For example, in fruits, we have apples, oranges, bananas. They have separate groups. So, clustering customer complaints to detect emerging issues in product lines. Next, we have information extraction, uh, pulling structured data from unstructured data. For example, extracting names, location, or product specification from user reviews. Then we have a final part of the text mining, sentiment analysis. Determine the emotional tone before behind a piece of text used widely in marketing. For example, analyzing customer reviews or new iPhone to public sentiments. Now let's move to the multimedia mining. This involves mining audio and video, which is growing rapidly with platforms like YouTube, TikTok, and podcasts. It has two subcategories: audio analysis and video analysis. Audio analysis call centers use speech to text and emotion dictation to access customer satisfaction during calls. You sometimes heard that somebody is recording your voice or call or messages. Then we have video analysis. Retailers analyze in store surveillance video to understand customers' movements, pattern, or detect theft using AI. After multimedia mining, we move to the image mining. Image mining is the extracting meaningful information or patterns from the images on web page. So there are three different subcategories of image mining: image recognition, image classification, object detection. So, first, image recognition used in e commerce, for example, recognizing a product from a photo uploaded by a user. Then we have image classification. Medical imaging uses this to classify X ray or MRI images as normal or abnormal. And then we have object detection. Self-driving cars uses object detections to identify pedestrians, traffic signs, and other vehicles in real time. So we have object detection, image classification, and then we just look at the object where exactly the problem is. So these are the image mining. Now, the final part, application in business analytics of web content mining. So we have three subcategories. For example, sentiment analysis of customer reviews. Then we have a new article classification and spam detection, content recommendations. So there are basically four. So let's see what is a sentiment analysis. We already covered this topic in first lecture. So sentiment analysis of customer reviews, brands like Amazon and Samsung monitor reviews trained to uh, detect dips in product quality early. Then we have a new articles classification. Financial firms classified and analyze news to predict stock movement. And finally, spam detection. Email provide like Gmail filter out harmful or irrelevant emails based on the spam classification models. And finally, we have content recommendation. Uh, Netflix or YouTube analyze view history and content metadata to suggest personalized content. In nutshell, web content mining is not only about extracting useful information but also understanding what people are saying and observing their behaviors, what they are seeing and sharing online using the insight to make better business decisions. So, in this slide, we covered web content mining, their usage, applications, and their types. Now, next slide, we are moving to another topic, that is structure mining, and then we cover the usage mining in last. This approach focuses on how web pages are connected to one another through hyperlink, and how entire web page or subset of it can be modeled like a graph or a network. How to grid them, combine them. Imagine the internet is a giant map. Each web page is a node, and every hyperlink is a road connecting those nodes. Web structure mining help us to navigate this map intelligently. And let's break down the key techniques shown here. So, number one, web structure mining core concept. This is the fundamental idea of analyzing the structure and topology of website. We are not analyzing the content itself, but how pages related to one another through hyperlinks. Use case: e-commerce sites analyze internal linking to optimize user flow and improve page authority for better SE for better SEO. Next, we have link analysis. This involves studying how web pages are linked to uncover relationship and importance. Which pages link to which, we can infer relevance, influence, and even detect manipulation or spam. For example, competitor SEO analysis uses link analyze to examine where rival websites are getting backlinking from. Business can then reach out to the same domains to gain traffic and authorities. Third is page rank. Google's ranking algorithm, the most important and critical part. Page rank is one of the most famous algorithm developed by Google. It does not only count the number of links associated with the web page, but it also evaluates the quality and importance of those links. If a high quality, reputable page is linked to yours, your page becomes more authoritative in the eyes of the search engines. Business impact: digital marketing use page rank inspired tool to audit their backlink profile and improve their search engine rankings. Number four, hits, which stands for hyperlink induced topic search. Again, hyperlink induced topic search. Hit identifies two types of pages. Number one, authorities, and number two, hubs. So, authorities pages with a valuable content, and hubs pages that link to many authorities. This is particularly useful in topic based search where you want not only trustworthy content but also good aggregators. Aggregators. For example, in healthcare, domain hits help identify authoritative uh, authoritative research articles and that size that frequently link to them, such as health blogs or medical forums. So hits is very critical and important in searching domain specific subjects. Number five and the final, web graph mining. This is a technique treats a web as a network analysis to discover hidden structure of the web page. Two common sub techniques. Number one, community detection, and another is called path analysis. In community detection, graph groups of closely linked web pages, for example, all blogs in a niche, are combined together. Path analysis is finding efficient link pathways helpful to site design and crawling optimization. For example, business example, a new aggregator can detect clusters of political similar websites or advertiser can find tightly knit communities to target with specific campaigns. For example, if you have a school, if you have some sort of courses, you can easily target the audience using web graph mining. Let's now look at how web structure mining is applied in real world in business context. Web structure mining doesn't analyze the content of web page. It analyzes the structure of connection between them using concept from graph theory and network analysis. By studying how web pages link to each other, we can extract meaningful insight that power everything from search engine to social media analysis. So first application is search engine ranking. One of the most well-known application is ranking website in search result. Search engines like Google use link analysis techniques such as page rank to determine the importance of a page based on how many other sites link to it and how authoritative those links are. This allows user to get the most trusted and relevant information first. Now let's move to second application, website navigation improvement. Companies nowadays also analyze their own web link. Using analyzing their own links, company can identify which pages are too deep in the site and hard to reach. And also they promote key content more efficiently, and also they improve user experience and conversations. Number third application is community. Community detection is a social network on social platform. Web structure mining helps uncover cluster of closely connected user or pages. This is valuable for target marketing like reaching niche or influencer groups. Trend analysis such as finding Emerging online movements. Then we have recommendation system by grouping similar interests. So now final application is spam detection. Web structure analysis also crucial in detecting spam websites. Spam sites often come from unneutral links patterns such as large number of irrelevant outbound links, backlink rings created to manipulate ranking. Although algorithm can flag and filter out these low quality pages to improve content credibility. Now let's summarize the topic in next slide. Now let's summarize the topic. Web structure mining analyze how pages are connected, not what's on them. It uses link analysis and web graph mining to extract structure based insights. Their application including improve search engine result, optimizing navigation, detection communities, and eliminating spam. So, in business analytics, these insights are key to boosting visibility, test trust, and user experiences. Now, in nutshell, web structure mining helps business not just understand what being said online, but also who is saying it and how everything is interconnected or connected. It is a foundational technique in the digital strategies toolbox. Now let's dive into last topic, web usage mining. We will cover user behavior analysis, page visit, click stream, search queries, and others. So first of all, what is web usage mining? It is a tool, a powerful tool to understand how a user behaves when they interact with the website. So unlike content or structure mining in the previous section, in previous slide we learned structure mining. Web usage mining focus entirely user behavior, what user clicks, search, visit, and how long it will stay on the page. So now let's move to the user behavior analysis number one. This is the core focus of web usage mining, uncovering patterns in user interaction to improve digital experiences and business outcome. Next, we have page visits. We begin by tracking which page user visits. This helps us identify popular content, bounce rates, and where user might be dropping off. Then we have third, click stream. Next, we analyze click streams, the sequence of clicks a user make on a a website. This relevance, this reveals user path, decision making flow, and potential bottlenecks. And finally, we have queries. We also look at what users are searching for. So this shows us the intent of the user, whether the site content meeting the user needs or not. Next, we have data mining techniques. Finally, we use various data mining methods like log file analysis. This is to study the user activities. And then we have session analysis to group behavior by session goals. And then finally, we have OLAP and data warehouse to store and analyze large scale data trained over time. Let's move next to the application of web usage mining. Number one, website personalization. Number two, recommendation system. Number three, targeted advertising. Number four, website design improvement. And number fifth, fraud detection. So, what is website personalization? Using insight from user behavior, website can adapt content and layout dynamically for each user, improve engagement and satisfaction. Then we have a recommendation system. By analyzing click stream and search queries, business can suggest a relevant product or content, increasing conversations. Then we have a targeted advertising. User behavior profile allow marketers to deliver preciously targeted ads based on interest and browsing patterns. So this is like we can target some audience where we are going to do some campaign or advertisement for any particular product. Then we have design improvement of the web page. Final fourth one, sorry. If we see where user gets lost or leave, we can redesign navigation flow to make website more intuitive and effective, more interactive and effective. And finally, we have fraud detection. Unusual patterns like rapid clicking or some odd browsing flagged are for potential fraud. So this will enhance the security and make sure it is safe for the usage. So now let's summarize why it is matters. Web usage mining turns every click into a data point. By analyzing user path, searches, and session, business can deliver smarter, faster, more personalized online experiences, whether for e-commerce, banking, education, or media. So, in nutshell, ultimately, web usage mining empower business to move from guesswork to data-driven decision making, helping website become more relevant, responsive, and result-oriented. Next, we discuss about the challenges in web mining. As a powerful as web mining is, it doesn't come without its challenging. Let's briefly explore the key obstacles business and researcher often face when working with the web data. So number one is data volume. Number two, data variety. Number three, data velocity. So number four, data veracity. And number five, scalability, and number six, privacy concerns. So four with the data and scalability and the privacy. So let's start with the data volume. So what is data volume? The sheer amount of information on web is overwhelming. Processing this massive scale of data requires significant computational resources and efficient algorithms. So we know internet is producing millions, trillions GBs, terabytes of data in a single second. So managing the data, processing it with limited resources is a challenging task. Then we have a data variety, means heterostructure of the data. Data can be simple, data can be audio, video, and data can be structural, like scattered over the different parts, like HTML tags and unusual data, star words. So it's not a managerial homogeneous data, is unstructured data. Then we have a data velocity. Web content changes rapidly, of course, and continuously. So web content is changing according to the requirements. So it's difficult to keep the same data for the same analysis is difficult task. Whether it is trending topic, real-time user interaction system must be able to analyze as data flows. Then we have a data veracity. Not all web data is reliable. Of course, there are fake news. It's difficult to find which news is accurate and authenticated, and outed content. Web mining, including balancing validation and quality checks is also a challenge. Then we have a scalability. Scalability means algorithm used for web mining needs to scale efficiently with the data growth. Of course, data is growing all the time, so algorithm should be also be growing itself. So web content mining include the validation and quality checks also. Sorry, when processing million of page users means we have to deal with the scalability of the page. Then we have a privacy concerns. A privacy concern in web mining often involves tracking user behaviors, which raise ethical and legal questions. Respecting complying with the regulations like GDPR is a critical. So we have to be careful about ethical values and all. Now let's move uh, to conclusion and to wrap up. The web mining is a vital component of modern business analytics. By combining data mining, machine learning, and NLP techniques, it allows organizations to understand performance, deliver personalized experiences, make data driven decisions. As the web continues to grow in complexity and volume, web mining will only become more essential, not just for business but also for research, governance, and innovations. Thank you for watching this lecture. I hope this helped clarify web mining works and why it's a such valuable tool in digital era.
There were two parts of the lecture one. In first part, we cover the basics, fundamental applications, and usage of NLP. In the second part of lecture 2, we discuss how NLP is going to affect on the business and how decision making is important by using NLP and impact of NLP on overall companies nowadays.
In the end, I would recommend, if you want to see a real time use of the web content mining or web mining, you can watch the series called Keyword Extraction using NLP as a Python project on YouTube. You need to go to the YouTube and search Himmat Academy, and then you can find the complete series from part 1 to part 6, where I have used a web page data, web page text to extract keywords. Thank you for watching.